I noticed that render elements are difficult and challenging to understand for many RVs artists, so I decided to create a short video explaining all the important information about them. In this video, you will see how to tweak different objects in post-production, how to control essential aspects of the image like overall light or reflections, and how to add in post-production depth of field or fog. So let's dive in. To start, open the render settings and go to the render elements tab. Here, we can add the elements we need. You will notice that they are categorized by the names in front, like C Essential, C Geometry, C Info, Mask, and more. In this video, we will focus on the masking and essential render elements, along with one from the geometry category, as these are the most commonly used in the industry. First, let's add a few from the masking category, like Wirecore, Mask, and Cryptmat, three of the most frequently used. Click OK to add them and start the interactive or production render to see the result. Now, from the drop-down menu, we can see the render elements we've added, as well as the alpha. Let's take a look at the Wirecore element. This render element will mask all the objects with the colored mask, matching their wire cores in the scene. However, we can immediately spot a common issue. If we have two elements with the same wire core, they will share the same core mask in the render element, which can cause them to merge into one large core. The next masking render element is one of the most used in the industry, and although I consider it as a legacy workflow, it's important to cover it since many studios still rely on it. Switching to mask element, you will notice that nothing appears initially. Let's stop the interactive render and select the mask render element to check its settings. As expected, it requires object IDs or material IDs to function, so let's add some to see how it works. Select an object, in my case, the table. Right-click on it and assign a unique ID. This way, we can mask multiple objects based on the object IDs. Next, open the material editor and add a material ID from the drop-down menu. Now, enable one of them, like Object ID. You will notice that the table appears in the mask render element. You can also enable material ID, but you will quickly see the limitation. Just two IDs, meaning we can only mask two objects. We can also use RGB mode, which assigns red, green and blue instead of a single white core to mask elements. Again, you can choose whether to use object IDs or material IDs, but this still limits us to just 3 object masks with unique cores. To summarize, while it's nice to have control over the masking cores, we are limited to just 3 masks per masking element. We can add more mask render elements to cover additional objects, but in a normal scene this would result in a large number of masking render elements. And guess what? All of these consume a small amount of RAM. So if we need to cover 40 objects, for example, this could eat up our memory. Plus, the manual work to assign unique IDs can be time consuming. Let's move on to my favorite one, the Cryptmat. With Cryptmat, you will see that all objects are automatically covered with different colored masks. Additionally, when we look at its properties, we can see that it can generate masks based on various criteria, such as materials, objects, and more. Now it's time to save the render elements. You can choose to save only the current render element in the VFB, the Cryptmat in my case, or save all of them at once. Be sure to give them a name. Here's the tricky part. To preserve the full color range of our renders, we need to save them in a 32-bit format, which is the EXR file format. Keep in mind that the files will be larger, but this offers much more flexibility. But what that range means? If you compare two images of the same render, a JPEG and an EXR, you will notice the difference. The EXR preserves information in overexposed areas, while the JPEG will appear flat. The same goes for the darker areas. I've seen many various formats used to save images, like TIFF or Targa, but EXR is the right file format for our needs. When you click Save, make sure to select 32-bit to ensure you are saving the full range. Let's click OK and open Photoshop. Now you see all the render elements saved as a separate EXR files. Select all of them and click Open. Photoshop will recognize that we saved automatically the alpha, so it will ask whether we want it transparent or as a channel. With it, we can change the background image if we want. I will leave it as a channel for now. After that, we need to copy all the render elements into one file, which can be time consuming if we have many elements. You can isolate each one to view it by using Alt+click, which I will be doing a lot in this video. We will start with the wire core element, where users usually try to select masks from it using the magic wand tool. Unfortunately, this doesn't work in 32-bit mode. The select core range option also doesn't work in 32-bit. To mask something using wire core, you need to convert the image to 8-bit. But as we discussed earlier, some cores may merge, making the masking render element basically useless in most cases. True, I still see people using it. Next is the masking render element. This one is straightforward. In the channels we have R, G and B representing the red, green and blue colors in the image. To select a mask, simply Ctrl+click on the channel you want. In my case, Ctrl+click on the blue channel to select the blue mask, which corresponds to the floor. Now I can go back to the main layer and apply a core correction to just that object, or make a copy of it and correct only that, preserving the original. And voila! We have our first masked object in the render. However, the fact that you need to create so many different mask render elements to cover all objects makes this method time consuming, which is why I tend to avoid using it as well. Taking a look at the Cryptmat, you might wonder why it's my favorite if, just like the wire core, we cannot select masks from it by its color. Well, let's see how to enable its full potential. First, save the file again, but this time as a CXR, Corona EXR. Now, close Photoshop and install a free plugin. Don't worry, it's free and you just need to click next a few times. It's widely used in the industry with the Cryptmat render element. Usually, I don't like tutorials that require installing additional software, but in this case it's something that is not only widely used but also a lifesaver, and it's absolutely free and easy to install. Open Photoshop again, rename the CXR file we saved to EXR and open it. The new script will ask a few questions. Let's leave the default settings and click Open. We can see how easily we saved so much effort. First, all the masking render elements are here, stored in a single file, so we don't have to copy each one of them. Also, the image is 32-bit. But the interesting part is below. Thanks to the Cryptmat and the plugin, all the masks are saved as a separate layers, allowing us to select something and core correct it. Basically, with this workflow, we don't need to copy all the files to one place because we have all the masks here. The best part is that we have all the objects in the file as different masks without assigning any IDs. If you want to go even further, I will leave a link in the description for another script that will break the image into masked layers directly. However, I won't show it now because 2 additional scripts would be too much for one video. Let me know in the comments below if you want to see it and I will make a short video for it. It's time to take a look at the essential render elements. Basically, each render consists of different, let's say, aspects like reflections, refractions and lights that are combined into the image we see. Here are all these aspects. We may not have some of these in our render, like the emissive and volumetric elements in my case, because I don't have any emissive materials or volumetrics. However, I will add all of them because I usually don't think about which ones I need. Now when we render, we can see in the render elements that all of these aspects are here. The direct lighting in the render, the emissions, which will be empty since we don't have emissive materials, the indirect lighting, the reflections, and the rest. Essentially with them, we can analyze our images. But the most important thing that is usually skipped in tutorials is that we can recreate the RGB channel. We can combine and control each one of them. Imagine being able to easily change only the reflection in the image, or just the direct light. Let's see how. Save the file as we already discussed and open it in the same way we did before. Seeing the render elements list growing, it would be daunting to copy all of them one by one into a single file. Also, the masking render elements are here as well. I'll select only the essential ones and put them in a folder to be able to control all of them easily. Isolate that folder. I'll select them again and change the blending type to linear dodge add. Okay, we have all of them combined, and if I isolate the RGB, we will see that there is no difference and the RGB is absolutely identical to the combined elements. Now we can reduce the reflections or increase the overall lighting. For example, change the color of the reflections only. By duplicating the reflect render element, we will end up with twice the reflections. Thus, we can control all of the imaging gradients separately. But that's not all. In combination with the Cryptmat, we can select only parts of the essential render elements and change them, like adding a lot more contrast to the floor only. Imagine what we can do with that combination of render elements. Change the shadows on the walls to be more bluish by selecting the overall light and making the direct light more yellowish. Change the reflection amount on some specific windows, and more. This is the true power of the essential render elements, to control each essential aspect of the image. From the geometry category, I will use only one render element, the Z-depth. You can see how the foreground is blurred in our image with depth of field. Unfortunately, this effect usually increases the render time. If we don't have a powerful computer, we can fake that effect in Photoshop using the Z-depth. Basically, this render element gives us information about the distance of objects from the camera, with the far objects appearing darker. When we start the interactive render, we will see the new element. It's almost black, except for the gray area, which is actually the wall from the model. The reason we don't see anything else is due to the settings. We have a minimum and maximum distance. Basically, the maximum distance defines how far from the camera we will see objects in the render element. Let's increase it and you understand. Setting it up to 300, we will see more objects from the scene. At 500, almost all of the interior is visible. In some cases, we can have a huge scene and we can measure the distance from the camera to the last object we want to cover. It's really easy using the tape measurement tool. The distance here is 561, but I will make it slightly bigger to round the number to 600. In Photoshop, we need to select all and copy the render element. Go to the channels and create a new layer. Paste it there. This will be our source for the depth of field. Now, click on the last channel and go back to the layers. Select the RGB channel. In the filters menu, choose Blur, Lens Blur, which, again, is grayed out in 32-bit mode. We need to convert it to 8-bit mode to use it. From here, we can select a focus point and define the blur amount. As you can see, the effect is not as good as it would be if created directly from the camera in 3ds Max. So my advice is to use the depth of field there if you have the time for rendering. Another way to use this render element is for creating fog, but you need to invert it first. Then we can either use it directly by changing the blending mode or by selecting it and drawing over it. Again, the effect will be much more accurate in 3ds Max, especially if we have volumetric lights. Okay guys, that was all for that video. I hope you now know how to create and use render elements and you will make even better renders in future. Till next time.